Hello everyone, this is Chidanand from Kratz Infotech NG. Welcome to this tutorial on Minikube add-ons. This is a kind of an extension of my previous tutorial in which I had demonstrated how to set up a single node Kubernetes cluster on a Windows machine using Minikube, which internally used Oracle VirtualBox as the hypervisor. Now, the latest versions of Minikube have got lots and lots of bundled in features in terms of add-ons. There's a whole lot of add-ons that is available, but let me pick three add-ons and then demonstrate what is the use of these add-ons, how to enable it, and then maybe for Ingress and metric server, how to utilize the add-ons to come up with an Ingress controller which will route the traffic based upon a URL pattern. And for metric server, maybe I will use an horizontal pod autoscaler which will determine the number of pods or the replicas of the pods, which will dynamically change based upon the CPU workload. So earlier in Minikube, we had to install many of these things by utilizing the relevant YML files or Helm charts. It is just that many of these are so very much required that Minikube has kind of baked in all these features as add-ons. So I'll quickly show you how to first enable this and then how to use maybe just three. There are a whole bunch of them, but I've just picked three of them. I just started my local Minikube and my Minikube version is 1.33.0. This is running on my Windows machine and this is my Minikube home and it is using VirtualBox as the hypervisor and everything else is the default. I did not change anything. So the memory, the number of vCPUs, everything I think is the default. CPUs is 2, memory is around 4 gigabyte and disk is around 20 GB I think. All right, and we are running Kubernetes 1.30.0 on Docker 26.0.1. All right, so now let me just quickly check the status of my Minikube. All right, so Minikube is up and running. So Minikube add-ons list. You'll see many of these add-ons are present. So typically whatever features that you would normally use in along with your cluster, that is kind of baked in using an add-ons thing. Otherwise also you can go ahead and install the relevant YML files or the Helm charts. So let me just pick a few of them. Maybe I will first pick the metric server because metric server is nothing but a kind of gatherer which will go and check the CPU and memory usage of all the running pods on my single node cluster. And where is metric server? Metrics server. Let me just copy this. So Minikube add-ons enable. All right, metrics server. All right, so metric server, that was pretty fast. Then let me also enable the Ingress controller. Now some of these are pretty simple. For others, it will have to download some Docker images. Everything is internal to Minikube, but if at all you were to run this on a proper cluster, for whatever Ingress that you kind of choose, there are lots and lots of types of Ingress controllers. By default, I think this guy picks up the Nginx Ingress. But then whatever Ingress that you choose, you'll have to look at the relevant documentation and there would be in all possibilities one YML or an Helm chart. Okay, so you'll have to just go ahead and install those or deploy those on your cluster. But in Minikube, everything is kind of pre-packaged and bundled in. It was stuck for some reason, but I was able to get out of that. And then let me just check Minikube add-ons list just to see if you will see many of them as disabled, whatever I wanted to enable. Storage class, no, that's not what I wanted. Yes, metric server is enabled. Ingress is also enabled. Now let me take a look at the dashboard and go ahead and enable it as well. Dashboard without any spaces in between. Minikube add-ons enable dashboard. All right. So now you would find all these add-ons enabled now. Okay, so enabling any of these add-ons, there are a whole bunch of other things as well. There's a registry server, there is Portainer, and so many that I don't even recognize some of them. But in case you would have a need to enable any one of them, the way to do it is as simple as that. Now let me take a look at few of these add-ons. The metric server definitely needs some time so that it starts collating all kinds of resource usage, and only after 5 or 10 minutes will it give me some good information. So let me first take a look at the dashboard that is up and running. All right, now if at all I say Minikube dashboard, all right, it opens up a simple dashboard. Okay, now you will not find any information here just because it is showing the default namespace. But if at all you want to see all the running pods and deployments and daemon sets and stuff like that, you will find all these out there. So anything that you're going to create on top of this, let's say a persistent volume, config maps, secrets, whatever Kubernetes components that you're going to create, everything else will show up here in this dashboard. It's very easy to take a look at it from a perspective of the UI. At one place, it's going to give you all this in a very nice, I wouldn't say very nice, but all right, pretty decent enough graphical dashboard. If at all I take a look at the pods, now this is the dashboard pod that is running with some information around it, Ingress controller. Let me take a look at, let's take a look at this dashboard itself. All right, so now this is takes some time for the CPU usage and other things to kind of show up, but right here at least it tells you what kind of an event that is coming out, what is the IP address of this particular pod, what is the QoS or the quality of service of this particular class, and what service account is this guy using. Pretty much all the information that you would find in your describe command in a nice UI. It kinds of shows that out very nicely, in my opinion. All right, now this is how easy it is to take a look at the dashboard. I wouldn't say this dashboard is very intuitive, very useful, but then pretty decent enough, and then without having to do anything other than enabling a dashboard. This is pretty good enough. If at all you like a little better dashboard, there is another dashboard called Portainer. Now, Portainer, in my previous tutorial, I have shown how to use Portainer for Docker. Now, even for Kubernetes, there is this dashboard available. Maybe I will make a separate video as to how to enable this for Minikube. Now, let me take a look at the next Ingress controller. So let me just quickly, I don't want to go into details of what is Ingress. I have some YAMLs. Now that the Ingress controller is already installed, let me just quickly put up a simple Ingress which will link a bunch of services. Now I will leave the documentation link so that anybody's interested can take a look at it. But most of this are referenced and copied from the Kubernetes documentation itself. This is Ingress. All right, so let me just spin up a couple of pods first. Okay, a hello pod and then a service. So let me copy this raw version of this YML and let me go back to my, okay, I don't need the Minikube dashboard anymore. So K apply -F. This will create two pods, or rather, sorry, one pod called hello app and then another service that kind of exposes it out. Similarly, there is another YML right in this folder, which is called welcome. One is hello, other one is welcome. Subtle difference between them is that the text that gets displayed. Okay, but then you have an application called Hello app and a welcome app. Each of them are run by different, are powered by different images. Right now it's the same image, but then with a different kind of a text. Okay, and also they are exposed through different services. One is called Hello service, other one is called welcome service. So K apply hyphen F. Now this is all the prerequisites for actually going ahead and creating our ingress. So if I say K get pod, two pods are running, K get SVC, there are two services running, hello service and welcome service. The default type of port is the default service type is the cluster IP because I did not specify anything. So now how to connect these two URL pattern? That's where we go ahead and define something called as an ingress. All right, so this is how you define an ingress, name of the ingress, and this can be running on any specific host, but right now it's all Minikube, so the host doesn't really matter. What is the path? /hello gets pointed to hello service, /welcome gets pointed to. This is how you connect these services with regard to the incoming URL pattern. So let me just go ahead and create this. K apply hyphen F. All right, so my ingress got created. K describe, there's only one ingress, I think. K describe ingress. Okay, now you see this example ingress that is running, and anything that hits the Minikube IP and then /hello gets routed to the hello service, and this is the endpoint, which is actually a pod that will print out hello, and this is again another pod which will print out welcome. So if at all I say Minikube IP, okay, this is the IP address, so I should be able to reach this IP address from here. /hello. Okay, now you see, and /welcome. Now the beauty of one of the important, or one of the most notable things about this ingress controls, if you want to change anything with the URL routing and rerouting and all that, you just go ahead and modify this simple ingress, which is pretty fast. Unlike you use a load balancer or a node port or any other type of services, it's very, very hard to fine tune or to connect them together. So in order for the ingress to work, we need to have an ingress controller, and using Minikube add-ons, I have enabled the default Nginx ingress. On top of that, I have deployed this ingress. Okay, last but not the least, let me quickly demo the metric server that got enabled. Hopefully, we should see some metrics. K top pod hyphen A. Okay, now you'll notice that the number of the CPU number usage will be spit out just because I've got the metric server up and running. So the metric server is very important. It keeps gathering metrics of all the running pods. Now, considering the real cluster, if you install a metric server of your choice versus Minikube, there's a subtle difference. There's a lot of delay in terms of these numbers that get collated, but then pretty much okay-ish from a perspective of running this like a dev environment. Now, let me showcase a very good example of a horizontal pod autoscaler, which will use this metric server to figure out what is the workload on a running, let's say, a deployment, and then scale the deployment, scale the replicas of the underlying deployment based upon real-time metrics. Okay, horizontal pod autoscaler. Now, this is nothing but another type of a workload object that sits on top of usually a deployment, or it could be replica set as well, where the number of pods would be dynamically increased based upon the real-time metrics, and that too typically either the CPU usage in terms of percentage or the memory usage. So for HPA, it keeps monitoring what is the usage of the CPU for a given deployment. And when you put up a metric server, you'll have to specify when do you want to increase the replica count. So we'll take an example where we will see that if the CPU percentage goes beyond 50% of whatever is the resource limit that has been set, then the deployment would be scaled up by the horizontal pod autoscaler. But in order for horizontal pod autoscaler to kick off all these things, it'll have to query the metric server. So we have enabled the metric server. A quick demo how to spin up an horizontal pod autoscaler, which will internally use the metric server. Now, Minikube metric server is not that great. There's a lot of lag in terms of the time that it takes. But then nonetheless, I'll just quickly show you how this horizontal pod autoscaling will work. Again, I'll refer to the documentation of Kubernetes, which is very, very good. All right, so let's spin up a Minikube Addons enable metric server, which you already done. So yes, first let me apply this, then go through this YML file. Copy, paste. All right, so all this that is present in the YML file is creating a deployment. There's a name of the deployment, some label, it's pulling up some sort of image from registry.ktest.io, and most importantly, it is telling what is the resource limit and request. Request is the bare minimum that it would need, 200 megs, and a limit should not exceed beyond 500 megs. And it is also exposing one service. Okay, so all this would do is spin up one particular deployment, and this number of replicas is not mentioned here, so that means it would be only one replica by default. So k get deploy, right? It's still trying to pull that image. K describe deploy. Okay, what happened? All right, it looks like it's scaled, pulled, and k get pod. All right, this pod is running, and k get replica set. There should be one replica set. Okay, so number of replicas is just one, because we did not specifically ask for any number, so the default one is always one. So on top of this deployment, create a horizontal pod autoscaler. Okay, now let me just copy this first and show you the YML of --dry run equal to client -o YML. All right, this is how you define a horizontal pod autoscaler. Now the whole metric based on which the horizontal pod autoscaler will kick in is the CPU percentage. The CPU percentage of all the pods. For now, it's only one pod, but whatever is the number of pods, it should not go beyond 50%. If it goes beyond 50%, then horizontal pod autoscaler will kick in, and it will try to manipulate the replicas from between 1 to maximum 10. Now the number of replicas gets increased just because the more the number of pods, the traffic would be kind of scattered around or distributed, so that the CPU percentage of the pods comes down. Now scale up, scale down, both are kind of supported. All right, so now let me just go ahead and create this. I'll remove this dry run equal to. All right, so k get HPA, horizontal pod autoscaler. Okay, so let me open up another prompt or a command prompt. All right, so in this one, what I'll do is I'll just say k get HPA -w. Yeah, just watch the pod. Okay, so if you see here, the deployment is just, I mean, the CPU usage is 50% because there's absolutely no load on or no traffic. Okay, so now we will generate some traffic by using this command. You can take a look at this. Doesn't do anything other than spinning up a busybox image and hitting that PHP service that we created. Okay, but the thing is, while sleep 0.01, okay, so in a very short time, going to go on creating a bunch of hits onto our server. All right, now this may kind of bring down my machine. So I'll possibly try to stop it as soon as the application comes up, and then the number of pods increase to some number. There's always a glitch because the horizontal pod autoscaler, which depends upon the metrics, there is a delay in terms of when that metrics would get collected. Let me also open up another command prompt and okay, get pod -w. Okay, let me also watch the pods. Now you see the CPU went up to a particular number, and the number of replica. Let me just stop this now. Just stop the traffic. Now you'll see here, this is the load generator that I stopped. But if you see here now, a bunch of PHP Apache pods started coming up. Now there's a delay because they have to pull the image, and my machine is a little slower. That would consider that. Now you see the number of replicas shot up to 3. And I've stopped the traffic, but then the whole idea is to demonstrate how to spin up an horizontal pod autoscaler, which will internally depend upon or rely upon the metric server and scale up and scale down the replicas based upon real-time metrics. I hope you enjoyed my video, and as usual, if you run into any issues, kindly leave me a message and I'll try to address it as soon as I can. Thank you so much for stopping by and watching. If you found these videos on my channel informative, kindly consider subscribing for my channel. Thank you so much.